Now on your left is an image of a healthy mouse spinal cord. On the right is an image of a mouse that's experiencing an animal version of multiple sclerosis. Now, how many people in this room know somebody who's affected by multiple sclerosis? Maybe a friend or a family member? For those of you that don't know what the disease is, it's a chronic, potentially disabling disease with no known curing cause. What we do know about the disease is our body's personal defense system, the thing that's supposed to protect us from virus and bacteria when we get sick, makes a mistake, and it starts attacking something found specifically within our cells, something that's found in the brain and the spinal cord. Now, when you look at this image on the right, what you can see is the two main commanders of this defense system, the T cell, shown in white, and the B cell, shown in blue, invading the spinal cord to initiate their damaging effects. Now, in the past, the main cell of interest in this disease was that T cell. We knew everything there was to know about the cell in terms of how it was getting into the brain and spinal cord and ways that it was leading to the disease damage. But when we treated patients with a drug that removed those T cells, patients didn't really get better. In contrast, when it came to the B cell, we assumed a lot. We thought that they followed all the rules that the T cell had to follow, and that their main way of contributing to the disease was through their ability to produce antibodies, which are kind of like specialized missiles that have specific targets to attack. When we treated patients with a drug that removed those B cells, patients seemed to do better on the drug. But the reason this shocked the field was this drug had no effect on the ability of those B cells to produce antibodies, which meant that those B cells were contributing to the disease in a way we've never seen before. Now, my research was aimed at trying to see how those B cells could be involved in the disease. We know these B cells can talk to T cells in places outside of the brain and spinal cord, like they do when we get sick with an infection. So my research was aimed at seeing whether or not those B cells were talking to the T cells locally within the spinal cord to initiate their damaging effects. But my research shows that these B cells don't behave like anything we've ever seen before. They're not following any of the rules that the B cells outside of the brain and spinal cord have to follow. In fact, they don't even follow the rules that the T cell has to follow to get into the brain and spinal cord. So the real mystery is, what are these B cells doing to contribute to multiple sclerosis? My data shows that there's certain functions here that these B cells are using that we've never even considered before, and I'm currently working on better characterizing them now. Canada has one of the highest rates of multiple sclerosis in the world, so even if we can understand this disease a little bit better, we can maybe make a difference. Thanks.